2, etc. 7 pi over 2. So naturally tangents behaves like this. Okay, so you will draw this tangents function. Then I would like you to draw also hyperbolic tangents function. Okay. So hyperbolic tangents, something like this. Then this naturally will be the first root. Then this will be second root. That will be the third root, etc. 9 pi over 2. So that will be the fourth root. Now paying attention that with the increase of the, so this is a root number. So that is a first root, second root, third root, fourth root. Maybe we don't see here very well. But with the increase of the number of the roots, the root's value gets closer and closer to which values? So this actually, look, here we are far away from this 3 pi over 2. Here we are a bit closer to 5 pi over 2. Then again closer to 7 pi over 2 and 9 pi over 2. So the solution asymptotically goes to this odd number times pi divided by 2. At infinity, so to say. At infinity, solution is very close to this value. Okay, I would like you to numerically investigate this phenomenon. Yes, sir? Look, please, if you are whispering to yourself, I cannot. Yes, go ahead. Number, there are first root, second root, third root, fourth root, etc. Then when so that is root number 1, root number 2, root number 3. When root number is increasing, then the root itself is getting closer and closer to pi over 2 times odd number. Any more comments here? Now, one more conclusion we would like to draw from, so that is a homework assignment. 6. Simply supported beam has symmetric and anti-symmetric mode shapes. So first is symmetric, first mode shape, phi1. Symmetric, what does mean symmetric? With respect to middle cross section. Okay. So that is this middle cross section. It is symmetric with respect to this. So that is axis of symmetry. And then second mode shape is anti-symmetric with respect to middle cross section. Cross section. Okay? The next one is symmetric. No, next one is also anti-symmetric. Sorry, this is the fourth one I depicted. That is first, second, that is fourth actually, and third will be like this. Okay, so third is symmetric. So symmetric and anti-symmetric modes are alternating with each other. You may want to write down. Symmetric and anti-symmetric modes alternate with each other. Okay. Now, why does this happen? Why symmetry? Okay, symmetry happens because boundary conditions are symmetric. Boundary conditions are symmetric. With respect to middle cross section. Okay. Naturally, that for simply supported clamped beam, we should not anticipate such a result. Because for the homework. Because in homework, we have non-symmetric boundary conditions with respect to the middle. So we cannot anticipate mode shapes to behave like this. Okay. Any questions? 7. Now 8. Our topic is number. Today we continued our discussion. We just finished, so to say, simply supported beam, more or less. Except, what is our topic number 16? I think. Can you tell me what is our topic number, sir? Can you tell me? Say it again. 15 was finished, yeah. Simply supported beams. $16 is what? Was a new one. Okay. So 16. Purely symmetric modes. We may look, please. We already obtained all modes. Okay, we obtained symmetric modes and anti-symmetric modes. We obtained all modes, both symmetric and anti-symmetric. But we may have wanted from the very beginning to obtain only symmetric modes. Imagine from the very beginning that we anticipate only symmetric behavior of the system. When this could happen? When, say, excitation is in the middle. If excitation is in the middle, then vibration modes naturally will be symmetric with respect to this mode. Or if excitation is a uniformly distributed load. Imagine we are giving uniform impact everywhere. Then there is no reason for antisymmetric modes to be excited. So the question is how to obtain purely symmetric behavior from the very beginning. Okay, one can say, oh, it's very simple. In order to obtain purely symmetric behavior from the very beginning, just solve the whole problem from the very start, and then look where do you have symmetric behavior and where you have antisymmetric behavior, and choose screen only symmetric. So that we already did. Just take first mode, third mode, fifth mode, etc. Take odd modes. So you may want to first answer that this way. This can be done by solving the whole problem from the very beginning, as we did already. And then picking only the odd modes. But this can be done better. This can be done better. We can do with less work. We can do better. So to do it better, then we can actually, let us see here. What is symmetric modes? Symmetric modes are modes where, so first of all, I can choose the coordinate system in the middle. So here, distance from the left end of the beam to the origin of the new coordinate system is L over 2. Okay, so here now we have y coordinate and x prime coordinate. Now what is symmetric mode? First of all, mode shape is denoted as W. So Wx prime equals W minus x prime. So that is a mode. That is what symmetry means. For example, here. So if I take some distance, specific distance here, then this is this mode shape. And on the same distance, we have the same value. This is what symmetry means. So therefore, it makes sense then to write W again as a sum of k functions. But instead of A, just take B, Bm. So B1, K1, B2, K2, B3, K3, B4, K4. Now K1 is an even function. Look, please. You have this sheet of paper I gave you that is hyperbolic cosine plus cosine. So K1 is an even function. 1/2 of hyperbolic cosine plus cosine. And now K2 and K4, K2 and K4 are odd functions. So therefore, for the symmetric modes, this K2 and K4 should not be present. Therefore, B2 and B4 must be taken as 0 from the very beginning. So therefore, the solution for symmetric modes should be like this. B1 K1 plus B3 K3. Because they contain cosines and hyperbolic cosines. The other guys contain hyperbolic sines and cosines and just sines. So this is a solution. The solution is in this new coordinate system x prime. alpha x prime, and here is alpha x prime. What are the boundary conditions? So we are dealing only, because of symmetry, we don't have to deal with the whole beam. We can deal only with half a beam. So boundary conditions then are, symmetry means derivative of W in the beginning is 0. That is what symmetry means. Okay? And this is ensured by this representation, because we already chose only such functions. And then another boundary condition will be W at L over 2 equals 0. So this is already imposed. Okay. Then in order to find symmetric vibration modes, we have to use WL over 2 equals 0, etc., etc. So now we have actually several cases. Let us deal with this. We have several vibration cases, and we will deal, we would like to deal with these vibration cases. So we dealt with one, simply supported, simply supported. So we can write down 17 actually. 17 are boundary conditions. When you write these numbers, please write them with very big, say, like this, 17, etc. Because in the future, when I'm asking what is a number, it's also easier for you to orientate yourself when you are reading. Okay. So boundary conditions. Boundary conditions are, we have the following cases. Look, simply supported beam of length L, simply supported clamped. So this you will be dealing at home. Then clamped free. Then clamped. Then simply supported free. And free. So there are in total 6 conditions, because we have 3 possible boundary conditions at every end: simply supported, or clamped, or free. Now my question to you is, which of them, okay, here we did find simply supported case does have symmetric modes and anti-symmetric modes with respect to middle cross-section. Which of the other beams we should expect to have symmetric modes and anti-symmetric modes? Say it again. 2 and 4, you said? 2 and 4. Why 2? It is simply supported clamped. Oh, I see. You mean symmetry from the point of view of W. I see. But do you remember? But here second derivative equals 0. And here in second condition, here first derivative equals 0. So therefore, here function and second derivative equals 0. Here function and first derivative equals 0. So therefore, this case is not symmetric from the point of view of boundary conditions with respect to the middle cross-section. They're actually different. So this case will not lead to symmetric behavior. But this case, you are right. This case would lead for clamped. The same boundary conditions are imposed. That is, W equals 0, first derivative equals 0. And naturally this one, free. Oh, you cannot see? What you cannot see? Oh, you don't see the pencil. Okay, we don't need the pencil now. Say it again. Oh, camera is frozen. Oh, I see. Okay, we need some help. Oh, hello. I think camera got a bit cold, or frozen as I'm told, and it does not move. So I cannot show anything here or move or something. Oh, it's here? Oh, okay. Thank you. No problem. Thank you. Thank you. Thank you. So in this free case, we can anticipate. So in three cases, simply supported, clamped, and free. We should anticipate both symmetric and antisymmetric modes. Now, I will actually make some conclusion about these cases, and later we will discuss when we will get to it. It is interesting that clamped, that these are the results that we will obtain. Clamped, and free beams share infinite amount of natural frequencies. Look, clamped beam has infinite amount of frequencies. And free beam has infinite amount of natural frequencies. But they also share with each other infinite amount of frequencies. This is very interesting. Because, look please, imagine you are getting information from outer space somewhere. And we have to identify what are the boundary conditions there. So if you get even infinite amount of information about natural frequencies, imagine they are giving you natural frequencies of the beam. So maybe some robotic equipment. Then we cannot say actually it is clamped or it is free because these two cases shares infinite amount of the same frequencies. Okay, it could happen. If the information that is transferred is infinite even information, but only those which are shared, then we cannot find. We need not only shared frequencies, but also some other frequencies that are not shared in order to be able to tell what boundary condition is there. Okay? Now, from here we see that even infinite amount of information sometimes is not sufficient to make a decision. Because if I will give you infinite amount of information, but such an information that is shared by two cases, I cannot distinguish them between two cases. Okay? Let us say such a vibration crime will remain unsolved. We will be unable to say which boundary condition is responsible what is happening. Clamped or free. So for example, if it is clamped, it may be okay for us. But if it is free, that means that in two locations, connections got loose. And it became free instead of being clamped in two places. But we are getting the same information, so I don't know from here to decide something went wrong or not. Okay, that is what equations will tell us. Second conclusion that we get is simply supported free and simply supported clamped beams also share infinite amount of natural frequencies. When I say they share infinite amount of natural frequencies, it does not mean that infinite amount of frequencies of the first coincide with appropriate infinite amount of frequencies of the second. No. Each of them have infinite amount of own frequencies. But between these two infinities, there is infinite number of things that appear both here and there. There are also some things that they do not coincide. There are also some frequencies that are not shared. I say infinite amount of is shared, but there are also some other things that are not shared. You may want to write down that not everything is shared. Any questions? Again, these are two stages, two separate stages. This beam and this beam both share infinite amount of natural frequencies. Okay, they have, let us say, imagine that these natural frequencies are letters that they are receiving, so to say. So we can say that these bones are getting the same amount of letters, so to say. Clamped, clamped, and free, free. There are also some letters that are not the same. For example, if there are two neighbors and they are getting many letters, very often letters are the same. For example, advertisement or letter of free offer of the new credit card. So they are sharing the same letters, so to say. But there are also letters that they are not sharing. Okay? So these two neighbors are sharing infinite amount of letters, the same type of letters, and these two neighbors also sharing the same number of letters. But letters there and letters here are different. There is one more minute. Yes?
Conditions are not in this two parts for supported, and clamped free.
Oh, why simply supported? Why what? Again, let me write down your question so that I understand it totally. Please ask. Why?
There are 6 boundaries conditions.
Yes.
So why the 2 others are not in the 2 parts?
Why there is no does not happen? The others do not have. So what you are saying, okay, what student is saying is we have here 6 combinations of boundary conditions. And why simply supported actually and clamped do not share. You see, when something is being shared, then it is something very interesting that should be explained why they are shared. But when they are getting different letters, when neighbors are getting different letters, it's very natural because they are different neighbors. So being different is natural because these are different beams, different boundary conditions. Only when they are sharing, that is something out of this world. But when they are not sharing, it's normal because it's different mathematical problems have different solutions. Have a good day.